Okay, so you're going to distribute the negative, so that gives us 2x minus 1. Now we can apply our next transformation, which is a translation 3 down. So that means I'm going to subtract 3 from the whole function, which I just think of it as you're doing it on the outside, right? Just minus 3. So now let's combine like terms, and that equals 2x minus 4. And there's my new function g of x. So again, you have to do each transformation separately. No shortcuts. All right, next one. Horizontal stretch by 3. Horizontal is weird, okay? That's when you're just replacing the x. That's it, right? You're replacing x, but you're replacing it by the reciprocal. So if it's a stretch by 3, we're replacing x with 1/3 x. But that's all we're doing, is replacing the x. So when you replace the x, it's really not that much work, right? You're just rewriting it as 1/3 x. A lot of you on the quiz put the 1/3 on the outside of the symbols. But that's vertical stretch or shrink. Horizontal is when you replace the x. All right, last, we have a translation of 2 left. Okay, that means I'm replacing my x. Again, translation is replacing x. Now, when you do this, this is the key. You have to put what you're replacing x with in parentheses. That's what most of you did not do on the quiz. Okay? So we're going to replace the x. So it's going to look like 1/3 times something. And that is left, so x plus 2. And then we have to simplify, which means you have to distribute the 1/3 to both terms. So now we get the absolute value of 1/3 x plus 2/3. We don't distribute it to the 1, so we still have a plus 1 out here. And then we still have the minus 4. And now we simplify by combining like terms. Here are my constants. So 2/3 plus 1, so that's 2/3 plus 3/3, which is 5/3. So we have an absolute value of 1/3 x plus 5/3 minus 4. And there's my new g of x function. So, again, you have to do your transformation separately. And when you translate left and right, you're replacing the x, which means you have to put parentheses. And then you have to distribute and simplify. And we missed a lot of that on the quiz. I'm going to leave you. You guys did really well on the quiz on number 3, so I think you guys can do that one on your own. I don't think you need to review that. My only reminder is that slope is change in y over change in x, so just make sure you put the y on the top. I think you guys are good with 4 as well. That went really well in the quiz, so you guys can do that one. Just, then write the equation in the line that's perpendicular. So make sure you read that. 5, you guys did super well in the quiz, so I think you guys can do 5. Maybe let's just go over 6 since you guys watched that lesson and I didn't do it in person. So maybe let's just do it together, just to make sure that's covered. So solve a system of equations by graphing, substitution, and elimination. So on the test, you are going to have to do all of them. So I will give you a system and I'll say solve this system by substitution. And then I'll give you a different system and say solve this one by elimination. So if you prefer one over the other, that's awesome, but I am going to test that you know how to do both. Okay? So, graphing. Let's isolate y so that we can put it in slope-intercept form. So I am going to subtract 2x from both sides and then divide both sides by this -1, which gives me the line y equals -5 plus 2x. And then I'm going to do my second equation. Let's add 3x to both sides. So 0 plus 3x is just 3x. And then let's divide both sides by 4. And we get y equals 3/4 x. Okay, so we have a y-intercept of -5. And then a slope of 2. Remember, slope is rise over run. So up 2 over 1, up 2 over 1, etc. After that, I don't even count. I just look, and I can tell. You can tell where the line's heading. And then our second line has a y-intercept at 0, right? 3/4 x plus 0. So rise over run, up 3 over 4. Oh, there we go. There's our solution. That's where they intersect. So up 3 over 4. And I'm not really going to finish the rest of the line. To at least have a point. Sorry, I'm awful at this. There we go. At least have a point on both sides of the intersection. Don't just stop once they cross. At least have 1 point here and 1 point here. So our solution is at 4, 3. Because that is where the lines intersect. So when I solve this system by substitution and elimination, I should get the same thing. For elimination, you get to choose which variable you isolate in order to substitute back in, but there's always going to be an easier variable. Look for variables that have a coefficient of 1 or -1. That's the easiest one. So I'm going to isolate y here, which we already did. Okay, we already isolated y here. So I'm going to take this and plug it in for y into my second equation. So we get -3x plus 4 times -5 plus 2x equals 0. Now I have one equation in one unknown, and I can solve for x. So distribute the 4, -3x minus 20 plus 8x equals 0. Combine your like terms. 8 minus 3 is 5x. Add 20 to both sides and divide by 5. So we get x equals 4, which matches. So that's a good sign. That means we did it right. And now let's plug that back up into the y equals equation so that we can get y. So we get -5 plus 2 times 4. So that's 8 minus 5 is 3. So again, we got x equals 4, y equals 3, which is good because that's what we got when we graphed it, so we know we're right. And then the last one is elimination. So I'll do that down here. We have 2 and -3 and -1 and 4, so y is definitely going to be easier to eliminate because I only have to multiply one equation. We already have opposite signs, so I'm going to multiply the top equation by 4 so that I have positive 4y and negative 4y. So we have 8x minus 4y equals 20. So 8 minus 3 is 5x. The y's cancel, and 0 plus 20 is 20. Divided by 5, we get x equals 4. All right, that probably seems super easy to you guys now after you did 1.4. Probably like, yeah, 2 equations, got this. All right, plug that back into the top equation. 2 times 4 is 8. Minus y equals 5. Subtract 8 from both sides. We get -3, so we get y equals 3. Which is good because that's exactly what we got for all of our other methods. I know there wasn't that much space there, sorry. Alright, how do we feel about, only a third of you turned in your homework. So how do we feel about yesterday's? Do we need to do one together? Okay. If there's a special case, do you want to do that one together? Okay. Alright, let's do the last problem, whatever number that is. Did yours get cut off by the hole punch? Did it? No? Okay, good. Mine did, which means I probably fixed it last year. Made sure it was good. Alright. Let's do, yes, this B. Alright, remember, never eliminate Z even if it looks the easiest, in case it is a special solution, and in this case it is. I think X looks like the easiest one because we already have an X and an X. So I'll probably eliminate X in the first and third equation because all I have to do is change the signs on the third equation. So I'm going to multiply the third one by negative. to get negative x minus 3y plus 12z equals positive 11. Again, biggest mistake I see in these problems is just dropping negatives. That's it. Or forgetting to distribute to the right side of the equation. That's really the big mistakes that I see. So now I'm adding the first one and this one. So x minus x is 0. 2 minus 3 is negative y. 12 minus 7 is 5z. And 11 minus 4 is 7. Alright, I don't know. I guess I'm going to use the first and the second. It doesn't matter. You just can't use the first and the third again. So first and the second, I'm going to multiply the top equation by negative 2. So I get negative 2x minus 4y plus 14z equals positive 8. And then I'm going to just copy down my second equation. 2x plus y plus z equals 13. X's cancel. Negative 4 plus 1 is negative 3y. 14 plus 1 is 15z. And 13 plus 8 is 21. So it doesn't matter whether you eliminate, well actually, it doesn't matter which variable you eliminate here. Let's eliminate y. So I'm going to multiply this equation. So that's a negative 3y, so we need to make this a positive 3y. So I'm going to multiply this equation by a negative 3, so that we get 3y minus 15z equals negative 21. And you can see those are all opposites, which makes 0 equals 0, which means that we have infinitely many solutions. Okay? Why can't I just stop here? Because if I just say it's technically not infinitely many solutions, it's infinitely many solutions on the line where the three planes intersect. So we need to write the equation of the line. Okay? Yeah.
When you did the second one, the solution of negative 1.
Yeah.
Do you have to do like two different ways? The first one we have to multiply
What do you mean? What do you mean? So here we had one equation in y and z, and here we got our second equation in y and z, so now we have a system. And so now we eliminate one of those variables. So then what was your question? Say that again? Okay. Okay, sounds good. Alright. So now we always let z equal a. Okay? So I'll just we already let z equal a, so we just need x and y, and we already know that z is a. We're trying to write all three of them in terms of a. So, where do I go from here? You plug it in to your, I guess we can call this your new system, right? Your system in two variables. Because we only have one variable, so we have to use our system of two variables to get the second one. So, it doesn't matter which one. I might use this one. So if z equals a, then we have negative y plus 5a equals 7. And we're trying to get y in terms of a. So let's solve for y. So subtract 5a from both sides. And then we need to get rid of that negative. So divide everything on the right side by a negative 1. And that gives us y equals negative 7 plus 5a, and we always write this in, we always write the variable term first, so we'll say 5a minus 7. It won't be incorrect if you don't, it's just standard form to write it that way. So now we have z in terms of a, we have y in terms of a, and we just need the third one, which means that we're going to go up to one of our original equations. I think the second one probably looks easiest. So I'll plug these in, and we'll get x. So 2x plus y, which is 5a minus 7. And if this was a negative, you would need to distribute the negative. Okay? But since it's a plus, it's just plus. And then plus z, which is a, and that equals 13. We need x in terms of a, so let's combine our like terms. We have 5a plus 1a is 6a. So we have 2x plus 6a minus 7 equals 13. So I'm going to add 7 to both sides to put our constants on the right side. That gives us 20. Subtract 6a from both sides. And we have 2x equals 20 minus 6a. We need to get x by itself, so divide everything by 2. And that gives us x equals 10 minus 3a. So we'll say negative 3a plus 10. A lot of work. I looked through your homework last night. It looked pretty good for those of you that submitted it. It looks pretty good. Some of you show more work than others. On the quiz, test tomorrow, test, not Wednesday for you guys. The more work you show, the better, because the more partial credit I can give you. So the more the better. The more organized it is, the easier it is for me to grade it and give you partial credit. But hopefully that was helpful. All right. I think you guys are able to do the rest. Let me just look over the test real quick and see if there's anything that I want to mention. Okay, we just went over all that. You guys are going to do that. You guys can do that. We're going to practice that. You're going to write, just like you did on the quiz, you're going to write an equation of the line of best fit, which I'll give you which data points you're going to use, just like you did on the back page of the quiz. You guys did really well on that one, so I'm not worried about that one. But there's not one of those in your review packet, so just letting you guys know that. And then we just did that, we just did that, we just did that, and we just did that. So you guys are pretty covered for the test. That's, yeah, the line of best fit, like you guys did on the quiz, there's not one of those in your review guides, but everything else is pretty much covered in your review guide. So, and then there is a take-home portion. So you guys are testing on Wednesday. Purple is testing tomorrow. There's a take-home portion. It is plotting some points, writing the best fit line of best fit, and then there are 2 systems on there like we just practiced. I'm going to give it to you guys today, and it's going to be due for you on Wednesday. Purple students, you'll get it tomorrow, and it will be due for you guys on Thursday. So you'll have tonight to do it. Or you can do it tomorrow night, since you guys don't have anything during class tomorrow, except for to study, okay? Do you guys want me to pass it out right now? Yeah. If you finish your review guide, I'll give it to you. So if you finish your review guide, just raise your hand and I'll come look over it, and then I'll give you the take-home portion. Let me just look over the take-home portion real quick. Okay, on the take-home portion, I probably shouldn't show you the answer. Alright, on the take-home portion, it says make a scatter plot for this data set, so you're going to plot the points. You're going to graph by 2s on the x and y axis, okay, just like it says here, but I just want to make sure you guys see that. Yeah, you're going to graph by 2s. Sketch the line of best fit through the bold points in the table. So, notice there are 2 bold points in the table. Just like I always give you guys the points. You're going to draw your line through that, and you're going to use those bold points to write your line of best fit. Okay? If you don't use those, it's going to be wrong. And then you're going to use the graphing calculator. So, if you guys don't have a graphing calculator at home or your own, then you probably need this in class today, so that you can at least do that portion, because you just got to punch these in and do your steps. Okay. So yeah, if you don't have graph calculator, make sure you get this before class ends today. And then the back, there's 2 systems. So. This is the assignment guide for chapter 2 starting on Thursday. It's a really short chapter. Yes, 1-4 day 2. So that was the infinitely many solutions, the special. So the system with special solutions. No solution. Last night or this weekend for Friday. Oh. Sorry. So you can do any combination of 2. You just can't, obviously, like I can do 1. Well, okay, so I can do like 1 and 2 and 1 and 3, or I could do any combination. It's just like sometimes if you look at the numbers